Hi there. Welcome to another Intel Tech Community Mailbag, also known as the Intel Tech AMA. I'm your host, Marcus Yam, Technology Evangelist at Intel. This is part 2 of our Alder Lake AMA, or as we're calling it,
Alder Lake AMA, the sequel. Even more ask, even more anything. Even more 12th Gen Core.
Now you might be wondering, do I need to have watched the first AMA to follow the plot of this one? No. But if you have, you'll already be more knowledgeable about our great 12th Gen architecture. So check out that link in the description below. In part 1, we covered questions about the 12th Gen Intel Core processor, codenamed Alder Lake, specifically the SoC and performance hybrid architecture, including the P-Core and E-Core that give it that special blend of performance and efficiency. And today, in part 2, we're going with the benefits of the new 12th Gen architecture, especially when it comes to new overclocking features and memory. A little background for those of you who are new to 12th Gen Core. Alder Lake features a new performance hybrid architecture that makes it one of the most unique processors ever. But don't just believe us. Tech reviewers also agree that Alder Lake is a winner. Before we begin, I'd like to give a special shout out to the mods and Redditors who sent in queries and the experts at Intel who supplied the answers, especially Tony, Amber, Nima, Alex, Dan, and Jason. Are they playing me off the stage like this is the Oscars? Wait, just one more. Aaron, Dynamic Memory Boost Maestro. Okay, this first question was asked a couple of times. One coming from JWCDIS and the other from Terminator Puppy. Sounds dangerous. How major is the performance difference between DDR4 and DDR5 on Alder Lake? And does DDR5 offer functionality that I would sorely miss on Alder Lake for gaming? And second, hi Team Intel, could you elaborate on the usage of DDR5/DDR4? What kind of performance gains will we get from workloads and gaming on the 12th Gen platform, and are there any disadvantages to using DDR5? First, games and most applications continue to depend on high-frequency cores. Better performance is required to drive high frame rates, a foundational element of achieving lower latency. This is where frequency matters and why we keep pushing the limits. With memory, we also see that there are games that will take advantage of the additional bandwidth that DDR5 will provide with speeds up to 4,800 megatransfers per second. There will be games that are sensitive to latencies, and this is where DDR4 may have an advantage. For now, some games like Hitman 3, for example, does better thanks to the bandwidth that DDR5 offers. In summary, we see a mix, and it just depends on the game. With regards to content creation type workloads, we are seeing the advantage of DDR5 with the increased bandwidth capability. DDR5 can bring even larger improvements once memory vendors start offering XMP 3.0 modules with better timings. But let me put it this way. If I'm putting together a 12th Gen based system today, I would not let RAM choice hold me back. Of course, if you have a specific workload that greatly benefits with going from one over the other, I encourage you to check out the great job that reviewers have been doing with their benchmarks. But either way, you'll find that Alder Lake runs great on both DDR4 and DDR5. This one's from Bazood. In the past, we've seen a few motherboards support more than one generation of RAM. Do motherboard vendors have the option to create boards with both DDR4 and DDR5 support, using separate slots, of course? Thanks for the question, Bazood. I think we could use a visual aid for this one. First, breakout and routing from the CPU would require expensive additional layers of motherboard design. Second, DDR4 uses separate power management on the motherboard to control voltages to the DIMMs, while DDR5 has power management on board each DIMM, again adding cost and complexity to the board. Third, given the routing distances allowed for DIMM slots to the CPU, they would likely only be able to do a 1 DPC layout of each type given the distance and vias. Signal integrity would not allow for the best overclocking. Unaccomplished Stud asks, is it true that some older games won't work with the hybrid architecture processors? No. Games run great on 12th Gen. What you may have heard is that some DRM or copy protection software saw the two sets of cores as two different systems. But the good news is that the fix has been identified and patches are already on their way. We've also been proactive with another workaround called Legacy Game Compatibility Mode that makes good use of the scroll lock key on your keyboard. So you'll want to look up exact instructions for your system's BIOS. Okay. RL48 asks, hi, will Intel be supporting GVT-G on iGPUs this generation around? Short answer, yep. The 12th gen Intel Core desktop processors enable Intel virtualization technology, which support features for processor graphics. All right. IHCED9 asks, why don't you launch chips with 64 XeEUs and more? When creating a SKU stack, we carefully weigh costs, performance, and customer demand needs, just like any other chip that you can buy. For desktop, we chose a design and SKU stack that aligns with the majority of users who have the option of discrete graphics. For laptops, that's a completely different story, especially in the thin and light segment, which is why you see some of these mobile processors have up to 96 EUs. That's the overclock, and you know what that means. It's time to tick the box and talk overclocking. Question from Cat6172. How will overclocking Alder Lake work? Do the P and E cores run at the same voltages and clock speeds by default? Can we overclock them independently of one another? Perhaps even underclock the E cores for less power or heat and overclock the P cores for speed. I like where your head is at. For overclocking, you have many knobs in the BIOS UEFI or the software, such as the Intel XTU, that you can play with. When it comes to E cores, you can completely disable them just to run the P cores, even all the way down to just having one P core. You need at least one P core for your system to boot up, but you can overclock the E cores and the P cores independently of each other. Now, mind you, they share the same power rail. Hope that helps. Question from Put It All on Black. Ian from Anantech says that there will be a one-click overclock for the 12900K, adding another 100 megahertz to the P cores and another 300 megahertz to the E cores. Will there be a similar feature available for the other 12th gen K SKUs? Good question. And yes, Dr. Cuttress is right. Intel Speed Optimizer within the XTU software is that one-click overclocking feature referenced. And yes, it is planned to be extended to the i7K and KF and the i5K and KF SKUs on or after version 7.6, but plans are subject to change and they should be available coming soon. Okay, next question comes from Tight Stops. Do you see a point where the industry will need to move away from traditional cooling fans and paste towards a newer technology in order to increase performance? What a super cool question. New material technology will likely pave the way for better heat transfer away from the CPU, but I anticipate fans will stay the norm for years to come. Fan and heatsink-based cooling systems are easy to set up and they're really reliable. There are other options to assist cooling performance, such as the Peltier-based cooling devices, such as the Intel Cryo Cooler, as well as the possibility of using the backside of the socket to aid in actively or passively cooling the CPU. And that's way better than turning your thermostat down to 273.15 degrees Kelvin. All right, next and final question. Drum roll, please. This question is from Technically Nerd. How does the new dynamic memory boost tech work in regard to memory training? DDR memory doesn't have frequency set points like LPDDR4 and 5 does. So how do you toggle between the two frequencies without retraining the memory each time? Also, will this feature be enabled by default, or will it need to be enabled manually by the user? Great question, technically. We asked Aaron McGavick, the mad genius behind Dynamic Memory Boost, and here is his answer.
Dynamic Memory Boost works by reading the SPD on the XMP memory modules in the system. XMP modules are required for dynamic memory boost operation and can be either DDR4 or DDR5 based on the topology of your system. The SPD contains information on the JEDEC base frequency and timings that the XMP module is rated at, as well as faster profiles that enable greater than JEDEC speeds. At boot, Dynamic Memory Boost attempts to train both the JEDEC base speed and timings, which is usually 4800 for DDR5, and then attempts to train XMP Profile 1, which is usually the least aggressive performance profile and the BIOS default. It stores both of these parameter sets internally, and then will automatically switch between the low and the high frequency on demand in real time when the memory bandwidth of the CPU crosses the default threshold value of 30%. In some BIOS menus, the motherboard vendor may expose the ability to change this threshold value and the residency time before transitions occur. This is an option that Intel provides. Since this feature is technically overclocking, Intel recommends board vendors set Dynamic Memory Boost to disabled out of the box, but you'll need to check your particular board settings to ensure you're operating as intended.
See? Totally genius. Okay, That's it for the Alder Lake AMA Part 2, the sequel of the Intel Technology Community Mailbag. Will there be another sequel called To Ask, To Anything? Alder Lake Drift? Be sure to subscribe so you'll be the first to know. And ask any questions you may have in the comments or at our Twitter handle @IntelTech. And keep a lookout for the next AMA on the Intel subreddit. Plus, you can check out all our shiny new explainer videos where we go even deeper into the details of the new 12th gen processor. You can find those links in the description below. I'm Marcus Am. Thanks for watching. I'll see you next time.